Hi everyone. So I'm going to go over the examples that I gave to you before we went on to our Thanksgiving break. This video will cover the first four. So in example number one, we see that we have 27 equals to x raised to the 3 halves. Our goal is to solve for x. And what we want to do is isolate x wherever possible. But in this case, it is fully isolated. So to get rid of this fraction, 3 halves, what we want to do is raise it to something that will cancel it out. In other words, the inverse of 3 halves, what would that be? Well, we know that if we multiplied 3 halves by 2/3, we would get 6/6, which would end up being 1. So our goal is to make this exponent 1. So what we can do here is raise the right side to the 2/3. But if we raise the right side to the 2/3 in an equation, whatever we do on the right side, we must also do on the left side. So I'm going to raise 27 to the 2/3 as well. Once we do that, then we could look at the right side. This will multiply out, will become 6/6, which is 1, which was our goal. So this will cancel out, and we will end up having x equal to 27 to the 2/3. Now from here, what we want to do is we want to evaluate 27 to the 2/3. Well, if you remember when we worked with fractional exponents, we can rewrite this as a radical, or you can go ahead and simplify this, do this mentally. So what it's asking you is to take the cube root of 27 and then square it. Or in other words, this is equivalent to writing it as the cube root of 27 and then square all of that. Well, what is the cube root of 27? What number times itself 3 times will give us 27? So if you said 3, you are right. So this is 3, and then I will square 3, and our answer is 9. And that is pretty much it for this example. All right, so let's go ahead and look at example 2. It's the same idea. If you want to pause this video and try this on your own, you can do that and then check your work with mine. So I'm going to look at this exponent. It's raised to the 3/4. I'm going to apply the inverse of that, is raising it to the 4/3. My goal is to cancel out using the power property. But if I raise the left side to the 4/3, I'm going to do the same with the right side. I'm going to raise it to the 4/3. And then using the power property, we get 12/12, which is just 1. So I'm left with m here is equal to 27 to the 4/3. Now, make sure you write your exponent small because it is an exponent. So what is 27 to the 4/3? Well, actually, the denominator is the root. So that's a cube root of 27, and then we're going to raise it to the 4th power. If you like, you can rewrite this as the cube root of 27, and then all of this raised to the 4th power. So what is the cube root of 27? Well, it is similar to the example before. The cube root of 27 is just 3. And then 3 raised to the 4th power means 3 times 3 times 3 times 3, which is just 81. So our answer is m is equal to 81. All right, looking at the next example, example 3. This one is a little trickier because we have a negative exponent, but we're going to do the same thing as we were doing before. We want to take our exponent and we want to cancel that out by multiplying it by its reciprocal. So if I'm going to raise this, and I want it to be positive 1, so I'm going to raise this to the negative 2/3. So if you look at these powers, when I multiply them, I have -3 times -2, which is +6, and 2 times 3 is another +6. That will end up being 6/6, which is 1. But remember, if we raise the left side to the -2/3, I'm going to do the same thing on the right side. I'm going to raise it to the -2/3. So this will cancel. I'm going to end up with x is equal to 1/729, but all of this is raised to the -2/3. Remember what a negative exponent is. So if I want to rewrite this as a positive exponent, if you recall negative exponents, I will just put a short review of negative exponents. We have x to the -n is equal to 1/x to the +n. Same idea, if I have 1/x to the -n, that just equals to x to the n. So using that idea, I'm going to rewrite this using positive exponents. So I'm going to rewrite this fraction as x equals to 729 raised to the +2/3. So now I'm left with 2/3, and remember this just means take the cube root of 729 and then square it. If I wrote it in radical form, it will look like something like this. All right, can you think of a number when you multiply it 3 times gives you 729? So I do know that 9 times 9 is 81. And then is 81 times 9 729? Yes, it is. So if you recall, 729 can be written as 9 times 9 times 9. So the cube root is telling me to take one of this triplet. Okay, so I have a group here of 3. The cube root is one of this group of 3. So that would give me 9. And then I would square that, which is 81. So our answer is x equals to 81. All right, and our last example, example 4, is a bit easier than the previous one. So what is the opposite of raising something to the 1/2? And recall, we can always rewrite this in radical form. This is just actually means the square root of r. Well, the opposite of square rooting is squaring. So what do I mean by that? This is equivalent to the square root of r. The opposite of square rooting is squaring, but this is already written in fractional form. So if I squared this, then I will square the left side as well. So you can see how the opposite of square rooting is squaring. This would be the same thing as doing it this way. I find it clearer to see when it's in fractions. You can see that 2 times 1/2 is 1. This is why this cancels out. So to continue with the above one right here, 2 times 1/2 is just 2/2, which is 1. So we are left with 7 squared is equal to r. And so therefore r equals to 49. All right, that completes the first 4 examples. In the next video, I'm going to do the next 4. So stay tuned for the next video.